Hello, good morning, everyone. Welcome to today's webinar on product sustainability. My name is Nick Exposito, Marketing Director here at TriStar, and I'm very pleased to introduce our presenter, Dave Duncan, VP of Sustainability at PTC. Before we get started, I want to do some quick bookkeeping and mention that a complimentary recording of this webinar will be sent to everyone who registered. As well, it'll also be available on our website and our YouTube channel shortly after. If you have any questions during the presentation, please feel free to leave them in the chat. We'll try to hold a brief Q&A at the end of the presentation if there's time. Before I pass it over, I want to go briefly over TriStar for those who may not be familiar with us. At TriStar, we specialize in helping manufacturing companies adopt systems and processes to enable better and more efficient product development. We achieve this by being the largest value-added reseller of PTC products and services worldwide, with representatives and engineers throughout the United States, Canada, and Mexico. We've been in business for over 25 years, and we're experts in CAD, data management, PLM, and product development. We also have a large assortment of custom solutions, services, support packages tailored to specific requirements and needs. But with that, just give us a moment, and I'll pass the reins over to our presenter, Dave.
All right. Yeah. Thank you, Nick. I'll just introduce myself real quickly, then switch off camera and we'll get right on to the presentation. Dave Duncan, I lead sustainability at PTC. I spend about 20% of my time cleaning up PTC's footprint, but 80% still in a product management capacity for sustainability capabilities on our solutions. And I think that 80% is what's interesting for this group, so we'll focus on that today. But if you do have questions on corporate sustainability, feel free to ask. Happy to answer those as well. So I'll flip off camera and we'll share our presentation and get rolling here. Okay. From the beginning. All right. Improving product sustainability. And we'll focus on some of the newer aspects of sustainability in this presentation. So a little bit on us in terms of, as a software company, our biggest emissions is greenhouse gases, and we're committed to reducing those and approved with our targets towards net zero sometime between 2040 and 2050. But more broadly speaking, and this is outlined in our impact report as well, which I urge you to read, we offer software solutions that help manufacturers design, produce, and service products more sustainably. So what's the problem? What are the areas that we focus on with sustainability? Or more specifically, where should a product lifecycle practitioner focus? And I use the term product lifecycle practitioner fairly broadly. It could be software engineering, CAD, mechanical engineering, PLM, manufacturing engineering, as well as service. There's really three areas, and the first is an old one. If you look at and we'll share this deck, it has some informative links as we go throughout, so you can link out and see some of the details behind these summaries. What you see here is the 9 planetary boundaries. These are 9 dimensions of badness that humans do to the planet. And the more it is outside of the green zone, the worse the problem is. Now, fortunately, there are technologies to bring all of these in, and we'll discuss many of those today. I'm not sure how old folks are on the webinar today, but I just turned 53. And back when I was in college, stratospheric ozone depletion was the biggest problem that was in the news. And in I think around 1990 or so, the Montreal Accords or Montreal Protocol figured out what the technology problem was with this, which was chlorofluorocarbons in our coolants. They found suitable replacements and banned the problematic chemicals from being used in coolants. So today we still have refrigerators, we still have cold beer, we live comfortable lives, and this has gone down significantly, and it's now our best boundary. So we'll discuss some other boundaries and how these boundaries come in with work that are done by product lifecycle practitioners. Let's start with novel entities. That's what the Stockholm Resilience Center calls really hazardous materials. And this is fairly old stuff. You're probably familiar with some of these compliance items like which is the electronic recycling mandate, where companies have to pay a little bit extra money to government authorities to recycle electronic waste that can no longer be thrown out into general trash. Then there's ROSE and REACH. So REACH covers hundreds of different chemical substances to, well, ideally ensure that those substances are not used beyond trace amounts in products. But if they are, then manufacturers have to go through rigorous certification that they are not harmful for the intended user and also not harmful to the environment at end of life. And ROSE is similar to REACH. It just focused on a few specific materials that, like lead and cadmium and mercury, that were commonly used in electronic components, but no longer really need to be used in those components. So it's covered the same way, just with emphasis for reducing those few chemicals. And there's a new one that is pending, that's not out yet, that starts to cover plastics, and PFAS would be the initial one, which are waterproof and other coatings that are effectively called forever chemicals. And they're on everything from umbrellas to waterproof clothing, etc. And this has not been legislated yet, but it's expected that it will come under similar legislation as REACH or ROSE, so many companies are preparing for that. The newer one is one of the two newer ones is decarbonization, which affects climate change and also ocean acidification. So as carbon dioxide is digested into oceans, that lowers the pH and increases the acidification of oceans, which causes problems in marine life. The governing body for this is the Corporate Sustainability Reporting Directive coming out of the EU, which not only requires European Union manufacturers to comply, but any exporter to the EU anyone that exports more than 150 million euros of product and service to EU, which is probably most of you on the call. If you are somewhat below that threshold, you're not required to comply with CSRD, but you will get considerable pressures in B2B contracts from European as well as other international customers that you may have to be compliant with some of these stipulations like we're about to cover for decarbonization. And the overlying method for this are called science-based measurements and reductions. We'll get to that shortly. So that's 2 out of 3, hazardous material controls and decarbonization. The third is circularity. The framework that you see on the left is the butterfly diagram, because it's shaped like 2 wings of a butterfly, from the Ellen MacArthur Foundation. The left wing are more organic compounds or materials. So you eat food, you digest food, food goes back to ground, it fertilizes soil, it creates more food. Generally speaking, our verticals don't deal much with these organic materials, so we're mostly here on the right, which are finite materials, metals, ceramics, etc. And the key point in this diagram is that recycling is not the best outcome. It's better to repair, refurbish, reuse before you recycle, because you preserve more of the value and the energy that was used to create those parts and assemblies and products to begin with. This is also governed by the CSRD. It has a longer runway than decarbonization. Decarbonization commitments have to start being made next year, more 2026 for US providers. They give international manufacturers an additional year, so you get to watch what the Europeans do first. But starting in 2027, specifically with batteries, manufacturers will be liable and accountable for the material that they sell to their customers in terms of that recovery. And there's stipulations there too that we'll cover. A couple compliance artifacts that are coming. Number 1 is the Environmental Product Declaration, the EPD. You see an example of this on the left. It looks like Greek, it kind of is, but effectively what this shows is it will show for any given product that you offer to the market, it will estimate the amount of environmental impact that it has, as well as resources that are used. Oftentimes today, this can be done manually, at a 5-figure expense per product. But more and more, as you offer a more complete bill of material, the bill of material can go into life cycle analysis functions and largely automate these for you. So we'll explain what sort of data and how that data flows to be able to do this automation. The next iteration of this is the digital product passport, which is the artifact for circularity. And you see an example here. Some of this is still being legislated, but the spirit of this is manufacturers are accountable for the materials that they sell. So they offer an EPD to their customers so that you can make an informed decision on the environmental impact of the product. But then it also tracks where that product is, as well as return spare parts to ensure that it cycles back into the economy. So batteries are the first to go in 2027. Other verticals follow. So consider the digital product passport more forward planning for you. All right, so decarbonization. This is what a commitment means. The vertical axis here is metric tons of CO2 equivalent. Corporations first need to take a baseline of greenhouse gas accounting. How many metric tons of CO2 do they emit per year? And based upon that base year emissions, by 2030, and that's a firm date, close to half of that has to be reduced. And some of this can be done through simple means, like acquiring renewable energy sources for your buildings and factories. And that's not something that a product lifecycle practitioner needs to worry about. Your treasury department and some of your capital goods purchases will take care of that. But the embodied carbon that are in the products that you manufacture, 25% of that footprint needs to be reduced by 2030. And that will largely be the focus of the session today. So that's the near-term target. And there's a lot of things that you can do to take down the easier and profitable aspects of that. Now, you have 20 years up to 2050 to do effectively the harder half, which is from your baseline year to be able to remove at least 90% of your emissions by 2050. Some companies might, for differentiation reasons, set a net zero commitment target date before 2050, but the latest you can set it at is 2050. And any remaining emissions, so the 0 to 10% of emissions that are left after your net zero commit date, those are ones where you have to buy a credit or offsets to cover that. Now, you don't have to buy offsets until your commit date. So it's likely that you won't have to buy your first offset until the 2040s or 2050 at the latest. The predicted price from the futures markets today is about $70 per metric ton of CO2 equivalent. So when you're trying to understand and calibrate what is the market price of carbon going to be, that's today's best estimate. And to give you an idea as to what this means, let's just say today was the net zero date for us. All of our companies committed to be net zero today, so we have to reach into our pockets and pay for an offset for anything that's left. If it's $70 per metric ton, you can buy some forest, but forest only covers part of the need. Oftentimes you need a machine to suck the carbon back into the air. What you see in the left side here is a picture of a Climeworks machine. They're a Windchill Plus customer in Switzerland. This machine happens to be in Iceland that will suck in air through an absorbent and then slam it thousands of feet into the ground for permanent sequestration. If we had to get our pocketbooks out and pay $70 per metric ton to Climeworks, a company like PTC, since we don't have physical goods, so our carbon intensity is fairly low, it wouldn't be that problematic. My CFO would be upset with me because I'd have to cut a $2.8 million check to Climeworks, but it's still below 1% of our free cash flow, looking at some FY22 numbers here. But for a $1 billion manufacturer today, a typical one, it would be a problem. A typical $1 billion manufacturer will have a baseline emissions of about 2.5 million, metric tons CO2 equivalent. And that can vary widely based upon the company and the vertical that you're in. If we take a optimistic margin of 15%, you're still over 100% of free cash flow. So what's happening in the markets today is the stock analysts know that these commitments are being made, and they will track your annual reporting that you will have to do through CSRD to see if you're tracking below your decarbonization line or above. If you're tracking above, that's problematic because your future earnings potential is lower. You have to buy more offsets than originally expected. So progress here can affect stock price or company valuation, and product lifecycle practitioners are the main lever that your companies have to reduce this. And we'll explain that now. All right, so where should we start? Now, fortunately, what we alluded to previously is the first actions that you should take for reducing your product footprints are actions you should take anyway because they're profitable. And McKinsey backs this up here with, on average, 20 to 40%. But if you look at OEMs and aerospace and industrial machinery, and a lot of us fall into this category or some derivative thereof, it's really your 50 to 60% of your footprint can be reduced with profitable methods today. And if we look at circularity, circularity offers significant profitability. Automotive and power gen have been doing this for a couple decades. And the value hill, we have a link to this here, it's a simple way to explain it to your business leaders. Effectively, as we make products, we extract some stuff out of the ground, we manufacture the materials or the components, we assemble the product in our factory, we ship it somewhere to retail, it gets to the user, and then the user gets value from it. If the user is done with that product or that product breaks, if you throw that product away, you destroy those 5 levels of value. It is much better to perform an activity that retains higher levels of the value of the product, like repair, or reuse or redistribution, refurbishment or remanufacturing of parts or assemblies. And only if you can't do those do you melt it down or shred it up and recycle before you throw it away. So this all sounds good and academic, but if you don't have design intent for these circular flows, it's really not commercially viable to do it. So more and more, like they've done in automotive and power gen, is there is design intent for these circular flows, which effectively requires modular design, since without modular design, you neither have the supply nor the demand for refurbished or remanufactured parts. Okay. And there's probably a mix of folks on the call today. I think most people are product lifecycle practitioners and they're learning about sustainability. We may have some sustainability experts that are learning about product lifecycle and how that can help meet sustainability goals. Either way, this diagram should resonate with you because for a sustainability lead, it looks like a lifecycle inventory flow. And for the rest of us, it looks like a classic product lifecycle diagram where your make parts coming through CAD take some materials and then you manufacture the make parts, but also as part of your bill of material, you have some buy parts and some components that you get off the market. They both come into your factory, you assemble the product, operate in service, and when either spare parts or the entire product reach end of life, they go through various waste streams, either thrown away or ideally reused, remanufactured, or recycled. Intuitively, you might think that the factory is your largest emitter for your product, but in reality, it's usually only between 1 and 10% of your emissions. It's where your most visible emissions are because you see the high energy use that's in your factory, but for discrete products relative to what happens upstream, it's a minority and it's fairly clean. Like let's take a steel rod as an example. A steel rod, back to the cradle, it is initially extracted as iron ore rock using heavy fossil fuel process in the mines. And then that rock is transported using typically diesel rail or diesel truck to a steel foundry, which uses fossil process to make these heavy steel rods, which in turn are trucked to your receiving dock at your factory. And sure, within your factory, you might put some screws in the steel rod, transform it a little bit, but relative to the energy and footprint of what happens upstream, it's quite low. If we look downstream for your products, some of your products may be electrified, others may be fossil powered. As part of the footprint of your product, you need to consider how much non-renewable energy is it going to use during its lifetime, and that is part of the footprint of your product. So if you have a fossil fueled product that you're manufacturing, that's problematic since there's only so much efficiency that can be gained um, with fossil energy. From the customers that we have talked to, which have been hundreds, the first thing that they do here is electrify. And then once you electrify, you're okay, since the electrical grids are on a trajectory over the next 20 years to be largely renewable. So the percentage of renewable electrons to power your product, you can take advantage of that in your footprint reduction program. So whether it's electricity or some sort of renewable hydrogen or other source, but the name of the game downstream is to get away from fossil power over the next 20 years in your product offering. One comment on upstream emissions up here is it's not just your heavy metals. Like the laptop that I'm presenting off of, it has an aluminum case, it has a big battery, keyboards, etc. The most carbon intensive portion of this laptop is the little lightweight CPU. And the reason for that is if we look back in the mines, if you take a big hunk of iron ore, about 80% or so of that is becomes steel. Whereas if you take a big hunk of rock for a rare earth metal, it's just a few grams of that rare earth metal that you get. So the carbon intensity of these little rare earth metals is substantially higher than the heavier metals, which is why electronics may often be your highest footprint contributor. All right, there's one other part to the story here that's essential, and that's the return loop. So using this laptop that I'm presenting off as an example again, we work with laptop manufacturers. A refurbished laptop with a like new warranty has about a 92% carbon efficiency compared to one that's made from virgin material. So it has 8% of the carbon footprint. And the reason why is the casing, the aluminum casing has a classic design. It's highly durable. It doesn't even need to be remanufactured. It can be reused in a remanufactured laptop. Now, the keyboard, on the other hand, might need some springs replaced. That would go through remanufacturing, but you don't have to go through all of the material processing and mine extraction for that keyboard again. It just requires a little bit of remanufacturing. And yes, the motherboard, the CPU, the memory chip, they're no longer commercially competitive if they're 5 years old. If you buy a laptop today, you don't want a 5-year-old CPU because of Moore's law and other things. So the best you can do with that is melt it down, shred it up, and then use that material to create a more modern CPU. But that does avoid all the banging of rocks or the rare earth metals. So you put those three waste streams together for a laptop, that's 92% efficiency. And to give another example on the other end, which would be a mining drill, right, significantly industrial, a mining drill is about 80% more carbon efficient. It can also have a like new warranty and be sold at a higher profit and a lower cost for the customer as well. So there's tremendous business opportunity in circularity, and frankly, it's essential for meeting your later phases of decarbonization opportunity. All right, real quick on these. I'm not going to spend a ton of time here, but I do want to leave you with this presentation and these links. These are some of the best design for sustainability frameworks that we've seen. A really easy one to start with is the LIDS wheel. It's general rules of thumb that really any product lifecycle practitioner could appreciate. We covered the value hill a little bit. These other ones get a little deeper. The deepest one is Design for X. If you're into ISO standards, ISO 14001 is the umbrella standard for eco-design and has reference to these other standards here. So we research these in our team and embed this guidance into our products over time. But here's a summary. If we were to summarize, what are the key aspects of design for sustainability? There are 3 levels of maturity, and academia backs this up. You can optimize at the part or component level, then optimize at the product level, then optimize at the product service system level, where you take into account after sales service as well as end of life recovery. And the key goals of each level is at the part level, you want to pick low impact material, use as less of that material as you can to meet the performance character or performance needs, and then find the most efficient way to manufacture that part. At the product level, that's where supplier components are selected. Also, suppliers of materials may be selected there as well. You can consider distributed manufacturing, which can save a ton of transport footprint for heavy and globally distributed supply chains, and tune the usage energy efficiency. What I would say more importantly, we'll cover this in the following slide, is hotspot analysis. And for product service system, is where you want to optimize the current life of the product. So how long can this bicycle really last in its current form? And then secondly, as parts in the bicycle become end of life, how do you circulate those parts and materials for secondary use in the most efficient way? But from a European tour that we did in the spring, where we talked to 200 manufacturers, for an established manufacturer, the preferred sequence of these steps is the following, is to start with the product. And the reason for this is, with this new CSRD regulation, one, you need to show transparency of what your current product footprints are with your environmental product declarations. And secondly, you can't redesign every part that you have all at once. You might find the top 1, 2, 3% of parts that have the most opportunity for improvement off of hotspot analysis, and then make those improvements in CAD or through sourcing if it's a buy component. And the next step, just because the regulation gives you a little bit more time for circularity, is bringing in system level considerations of product service systems, which involves, it's much more complex in terms of requirements management, since you have circularity aspects, commercial aspects, service aspects in these decisions. And ultimately, the compliance artifact is a digital product passport on this. So this is really the sequence of action that we've seen from product lifecycle practitioners from the first European accounts that need to abide by these regulations. And to repeat, Americans have, well, anybody that's not in the European Union, so that could be British Americans, Japanese, South Koreans, etc., have an additional year to figure this out. All right, so let's go a level deeper. Let's talk about things that you would do in PLM and CAD and ALM and SLM, etc., to facilitate profitable footprint reduction. So step one, a modular bill of material is the design hub. And maybe you're not modular on day one, and that's fine. But modular design would be an essential iteration as you start moving towards circular programs. But it's not required initially to track your footprint and do reduction of and find priority reductions. So this should be familiar with folks on the call. You have more than one or more materials that may roll up into a make part. You have your buy components here. You can have options, choices that roll up into a bill of material. Some new information that you need to manage in your bills of material include material information. Like you may choose aluminum or steel or titanium, etc., say for a bicycle part or bicycle frame. They will have different costs, carbon footprint, water usage, percent recycled content, recyclability of that material blend, and hazardous material compliance flags like REACH and RoHS. So I just rounded off, I think, 7 different attributes that you would probably want to synchronize with your material data sources at the material level so that you can roll those up. And you would look for similar attributes when you do your supplier component selections as well, But rather than having that parsed down to the material levels, your suppliers would need to provide that to you at the component level. And that's probably the only way that they would give it to you, because breaking it down further would get in their IP. And that's fine, because you just need to be able to roll it up. So if they roll up there at their component level, you would stuff those same attribute values at the part level rather than the material levels. Now within your factory, you're going to do some transformation, some assembly, put some energy into parts. It could be at various levels of your bill of material. There are ways to predict this through simulation, like a priori does a wonderful job of this. There are other ways through MPM and other methods to predict the amount of energy and scrap and other footprint that is added during the manufacturing process. And that footprint can also be added at the part or assembly level. And then you can roll this up, and that effectively gives you a fairly good prediction as to what the life cycle inventory of your product will be the moment it leaves the factory, in terms of how much embodied carbon, how much water was used from the mines all the way through your factory, how much is recycled content, how much is recyclable. Those are all questions that need to be answered by the CSRD. And early and often along the way, with a good quality bill of material, you can automate what's called a streamlined life cycle analysis. And view that as an environmental simulation. There's various providers for that. MakerSite is one, EcoInvent's another, Sphera, several others. And they can bring back data for you for its impacts, like on that environmental product declaration that we showed, and tell you if you're doing better or worse based upon your previous design and how you're tracking relative to requirements that you have. As you get near end of design, your bill of material is final and thorough enough where you could reasonably automate the environmental product declaration as a function of your bill of material information. And that will save you typically between $15,000 and $35,000 to otherwise do this manually with a disjointed system. Okay. All right. Now within that assessment of your bill of material, you will discover opportunities to improve parts, and some of those might be make parts. And within CAD, there are capabilities within CAD to help you do that. The first would be material integrations, where you might be able to select a better material that not only reduces the footprint, but it may also save you on some cost. And you will need to make that decision based upon performance constraints as well. So thermal expansion, stiffness, strength, other attributes can be selected for finding those materials. And next would be reducing that material. So with an original design, say for this e-bike steering stem, and we do have videos of this exact scenario that walks you through the process and the comparisons, you can do a few things. One, you can run it through generative design to remove unnecessary material. So it can run through a function that will calculate where can I remove material in this geometry that will not affect my performance constraints. And even using the same targeted manufacturing process as, say, casting in this point. So this would be a no-brainer decision. Like, why wouldn't you do this? It removes footprint, but it also removes cost of materials, and you still have the same performance constraints. Really, the only reason why you might not do this is if there's an appearance hit, like if this is a cosmetic part. But otherwise, if it's a functional part underneath the fascia, of course you do it. You could also consider other manufacturing processes with generative design, and then run it through performance simulations for to ensure that it holds up performance-wise. So you could look at milling. You could also look at additive. Now, additive will almost always use less material, but it frequently has a cost trade-off as well, since it is often more expensive to additively manufacture parts, and the throughput may be slower as well. But to understand what is the trade-off for the lightweighting You can have performance differentiation for a lighter stem on a motorcycle, better fuel efficiency as well, versus the cost, and the designer can make that trade-off decision. And the third is to tune the manufacturing process. One method to do that is to pump it through a manufacturability simulation, like a priori. That will advise you on how much footprint and cost is added during manufacturing, and advise you on any geometric, material, or manufacturing process changes that could be made to improve it further. Okay, so that's PLM and CAD. If we look at ALM, software, of course, is important in items, but for product service systems in particular, requirement tracing becomes important, and something that we are starting to offer with our design for sustainability best practices is we are codifying that in a requirements template in Codebeamer, so that design engineers will have access to these things to derive sustainability best practices, connect them to test cases, as well as design using OSLC standards. Looking a bit further into product service systems and digital product passports. So with the digital product passport, for any given serial number, its final environmental product declaration would be the birth certificate that is PLM source that would come off the factory line and seed a digital product passport. So on day one of, say, this electric bicycle, serial number 123, here's what's on it. Here, this is the embodied carbon that it took to create this bicycle, recycled parts, etc. And from this digital product passport, additional information is added to it over time in terms of who owns it, where is it, what parts have been swapped off of it, and what has been the disposition of those parts, how have they been returned and received back into the economy, which will prove all those regulatory things that are necessary there. So our asset digital product passport would be in ServiceMax Asset Hub. And this, to repeat, is something you really don't need until 2027 at the earliest. And only then do you need it. You only need it in 2027 if you have large batteries in your products. Otherwise, you probably have until 2029 or 2030 to offer these types of passports. Another comment here is this is not just restricted for OEMs. It goes down at least one, sometimes two levels of many supply chains. One example would be is, let's say I buy a 2028 Volkswagen electric vehicle. It could be a gas vehicle too, for that matter. Volkswagen would have a digital product passport for VIN number 123, whatever I bought. But if it had a LG battery and a Bosch motor in it as tier ones, it would point to Bosch's digital product passport for that motor and LG's digital product passport for that battery. So the tier ones are liable to host their own digital product passports that are inherited higher in the supply chain. So there is a burden to do that, but it's also an opportunity since it gives the tier ones more visibility, more access to their value chain for new business opportunities. So this is a fairly large concept. It has a bunch of PLM, well, I would say enterprise PLM, PLM plus SLM implications, but many business opportunities can come with this as well, since you have more intimate data about the real world performance and locations and ownership of your products. Okay. So when you look at product service systems, reducing footprint fully aligns with financial objectives. And the name of the game is for service planning, we discussed the merits of modular product design, since that facilitates both the supply and demand for refurbished and remanufactured parts. Design for connectivity with software. We'll give some examples of that. The service parts inventory optimization can reduce embodied carbon of your networks. And with modular design, an important consideration is, yes, you can offer more variation to your customers, But the problem is that can create a lot of complexity for your frontline workers, whether it's in the factory or service, since pretty much every configurable product that comes down the assembly line or inspection bay or in a service event looks slightly different than the one that the frontline worker saw previously. So using the configuration management intelligence to filter instructions and parts lists to be configuration specific becomes important for delivering quality manufacturing and service. So on the service execution side, the best, least expensive channel is if the customer can serve it themselves. The next would be is if you have to fix it remotely. And the only way you're going to fix a product remotely is if it's a software fix, because you can't change parts on your own or remotely. So as a result, there's a large shift towards including more software and even some software replacement of parts in the market. Like I recently got a recall for my car because of the window motors. The sensor was not sensitive enough, and a young child could hurt their fingers if they were playing with the window. But as I read down the recall notice, I was fearing I'd have to bring it to a dealer. They said, "No, don't worry about it. When you're asleep next Thursday, we will send you a software update to your vehicle and it'll fix the problem," since they dematerialized that sensor. It was purely a software sensor in my model year. So it avoided any mechanical parts at all in that regard. And then the next would be if you have to fix the product yourself, and that might be bringing it into a central bay or going to that product, is to narrow down what the possible problems are so that you can have the proper parts as well as instructions and skill set on hand when you're doing that service event. Otherwise, for a typical product, you may have 100 or more field replaceable units, but with remote triage, you can fairly reliably isolate that to 1 to 5 possible causes and prepare your truck or your maintenance bay with that material and instruction. And that avoids the dreaded repeat visit, which is double the cost, double the footprint, about 10 times the customer satisfaction hit. Okay, so the conclusion here is for these sustainability regulations, which will be the business driver for your sustainability program, starting in Europe, but then coming to all other geographies a year later, is start with cradle to gate. Optimize first where the regulation requires you to, and the techniques that we just showed make substantial reductions in those footprints and generally in profitable ways. And then as a phase 2, look at getting towards cradle to cradle, which will require a lot of, well, I wouldn't say a lot of, but it will require forward planning for modularity if you haven't done that yet. And then the execution of that more involves software as well as the service lifecycle as you get towards digital product passport. Okay, so Q&A. I'll conclude with this slide here just in terms of where to learn more. Our impact report goes through some case studies of customers that have made footprint reduction activities that were financially beneficial. We offer workshops. So I run workshops. They're no charge for PTC customers. So if you want to have a workshop, you can reach out to me directly or through TriStar, and we can get you signed up. Sometimes we travel around and do these on site. Other times we have them remotely, where we take you through greater detail of how the products are used to facilitate these improvements in commercially practical ways. We do have a user community as well on sustainability. You'd request membership through me. Happy to sign you up if you'd like to follow that. We cover a lot of the topics that we covered today, as well as some advisories on new enhancements that we do in our products to help cover a lot of these new regulations. And there's a good forum that's online called the PLM Green Global Alliance. It has over 1,000 members already, and there's a wealth of information. It's fairly active in terms of wisdom that's given. That's not specific to PTC. That's really across the industry as a whole. So with that, I think we promised to hold this to about 45 minutes. We're right on time. I'll pause, and if there's any questions, happy to answer them.
Yeah, guys, if there's any questions, feel free to put them in chat. So we'll pause for a few moments here. And if there's not, we'll go ahead and end a little bit early for you guys. But just a few reminders in case there aren't any questions. You'll be sent, if you register today, you'll automatically be sent a recording after this is done. It'll take a few minutes once it needs to process. We'll also have it available on our website and on our YouTube page, just TriStar CAD and PLM Solutions. Make sure you like and subscribe. And then we'll also send out a copy of this deck to everyone who signed up as well. So look for that later today, perhaps Monday, but yeah, we'll try to get it to you as soon as we can. So, all right, doesn't look like we have any questions. So thank you everyone for coming out and for attending this Friday. Again, thank you to Dave and for your time today. This was great, and we hope to do more of these in the future. So with that, just want to say everyone have a great weekend, and we'll see you soon.